Hello, good evening all. Uh, can you all hear me?
Yes, ma'am.
Yes,
Yes,
ma'am. Good
Yeah,
evening, ma'am.
so good evening all. So I'm Nikita. I will be the course instructor for Statistics 2. And today is the open session for week 1. All right, so I hope in last session you got your doubts clear from activity session, activity questions. Last session was activity session, right?
Yes, ma'am.
Yes.
yes, ma'am.
Ma'am, may I ask one question, please?
Sorry, can you repeat?
May I ask one question, please? I don't know how to do this extra activity.
How to do extra
Google Search.
activity?
Yeah.
Okay, so for extra activity, for the first extra activity, it's just quite easy. You have to just make your Google website and just publish it there. And the second activity was like you have to collect a data sheet and put it in your Google page, like the web page. So the details about the first two activities, you can find it in the first lecture of week 0, basically.
The first lecture of video.
Yeah. First or
And,
second.
it
Why the
is
first
regarding
or
how to
second?
make a,
Sorry.
it is about how to make the Google website and post the activity over there.
Yeah,
Right?
that is also there. Yeah, it is there. So like if you go to week 0 part 1, right, you can find the details what we have to do in the
Okay.
first and second activity. So just go and check.
That's what I wanted to know. I didn't know how to create a Google website and create a page in there.
Hmm.
So I will watch that video. Thanks, ma'am.
Yeah, sure. So we'll start our today's class now. So today is open session. So how many of you have watched the lecture, finished watching lectures, tried problems?
Yes, ma'am. I have finished.
I have completed up to 1.4, ma'am.
Completed up to 1.4. Okay.
Yes, ma'am. By tomorrow, I'll finish up the remaining 2.
Okay. What about others?
Started, ma'am. Actually, week 0 part was quite long. It's released with one on.
All right. So many of you, I see many of you posting questions on discourse regarding week 0. So I assume many of you are watching week 0 completely. So week 0 is just like an additional content, like a refresher week for what has been done in statistics 1 course. Okay. So I would suggest like, okay, now it's already too late, but don't watch week 0 for now. Like you start from week 1, and then if you feel something is missing there, you're not able to understand, and if you think that topic has been discussed in like starts 1, then go back to week 0, just check where can you find that video and watch that portion.
Okay.
Okay,
Okay,
Yes,
ma'am.
ma'am. Yes, ma'am. By 14th, we have to submit the
By 14th,
graded.
you have to submit the first grade assignment.
Yes,
That's
yes, graded. Yes, ma'am. That's why I
Ma'am,
watched only week 1, week 2.
ma'am, only graded assignment is
Week 0.
compulsory, no?
the only graded assignment is
Compulsory for every week.
Yes, yes.
yeah, credit assignment is compulsory for every week. Also, you have to submit the practice assignment and all. Like there is some
This is for practice only, no?
which one?
All the activity and
This is for practice and your own understanding. Like you will be graded on the basis of graded assignment.
Okay.
And it's on-demand session.
Sorry,
On-demand session.
on-demand session. Yeah, so on-demand session will also start like by next week, perhaps. So details will be shared with you. It should start by next week.
Purpose of them, like.
Sorry.
what is the on-demand session?
On-demand session as in like there are if you want more sessions, there will be a mentor assigned to you, and you will be like you will be solving problems. You have any doubt, the mentor will help you, and it's like that. So it will start from next week, and maybe not sure about the date for now. So whenever it starts, the details will be shared with you. Okay.
Anybody can join that session?
Anyone can join the session. Yeah.
Okay.
So, ma'am, in this session, we can ask some questions from week 0 if you, right?
Week 0. No, we are keeping the session for week 1. Week 0 is for your own understanding. Like it's for your own thing. Like if you have doubt, you can just watch the lecture. Also, if you go to the portal, right, there has been live session updated from the last term. So few things from week 0, regard, it's like all the distribution, like say Bernoulli, binomial, geometric, negative
It's not
binomial,
conceptual questions. These are like I have doubt some questions, questions that are given to practice over.
activity question.
Yeah, question from practice assignment. Week 0.
Okay, I would suggest, can you just once check the live session there, if it is there.
Actually, I was seen the solution also in practice assignment solution.
You have seen the
And is
solution.
available,
Okay.
but I have some issue with that actually.
Okay.
There's one question in particular. I have some issue with the solution given in the practice assignment solution also.
Which practice assignment you want?
So
you're talking
0.2.1.
0.2.1. Just hold on. Zero point 2.1.
Question number 9.
And nothing is visible on the screen.
Yeah, I will share this screen. Just hold on. I'm just checking which question. Question number 6, right?
Question number 9.
Question number 9.
Yeah,
Okay.
0.2.1. Question number.
Okay, so all this are very basic binomial distribution. It's a binomial distribution question, basically.
Yeah,
Whatever
but actually, it's not like there are 8 screws, but
Okay,
there's
I
no
will, let
particular
me
order
here,
among them, no? Like
let me share my screen. Wait.
Ma'am, please discuss all the concept related to week 1.
Concept related to week 1.
Yes, sir. Week
No,
0 has
you are
already been covered in the
you
text
are
online.
no, you are supposed to watch the lectures, and if you have any doubt, you can ask me. It's very difficult to cover everything at once, in one lecture.
No, actually, maths, they did it like that. You also do like this. The reason-
Maths 2 you're talking about?
Yes. They used to discuss the concept. They never used to solve activity question. They leave it to us, but that helped us. They discussed concept.
Yes, sir.
Yeah, because the thing is that.
Okay, first let's see this problem. Okay, I have just tell me what is the doubt here. After this, we are not going to take any question from week 0. Okay, we'll start from week 1. Okay, so here the question says a person has bought a bed from an online furniture store. Okay, the seller delivers the disassembled parts along with some screws to assemble it. Now you have a bed and it's disassembled, and to assemble it, you have some screws given along with it. Now the probability of a screw being defective is 0.1 independent of all other screws. Okay. To compensate for the manufacturing error, the seller sends 2 extra screws in the package where the bed need exactly 8 screws to assemble. All right. So total number of screws that is given is 10. Right? You need just 8 screws to assemble the bed, but the seller has sent 2 extra screws in the package. So you have total of 10 screws. All right. And probability of a screw being defective is 0.1. independent of all other screws. Now, what is the probability that the buyer will be able to assemble the bed?
So we take being the probability of non-defective the screw will be 0.9,
Yes,
and we
0.9.
take that as a success. If it is non-defective, we
So
can consider it as a success.
basically, if the buyer is able to assemble the bed, it means there are at least 8 good screws. It means
It's
non-defective.
non-defective.
So out
screws.
of 10, there are at least 8 non-defective screws in the package.
Yeah. So
Alright.
number of so the
So you have to
probability.
find, what is the probability that number of non-defective screws are greater than
8 or
equal
more
to
than
8.
more
Yes.
than or equal.
Right? So, and what is, when does a random variable models the binomial distribution? So you have many, the first thing you check is like all the cases that you take, all the draws that you take, everything should be independent. Probability of success for each of the draws should be same, right? All this you check. So in this case, you had that X models here. Let's say if I'm saying X models the number of non-defective screws. Okay, X denotes the number of non-defective screws, and you have total of 10 screws, and each screw, the probability that it is defective is 0.1. So the probability that each of these screws will be non-defective will be 0.9. So to find the probability that X is greater than equal to 8, you just have to find X is binomial, we know, right? So X is binomial with the parameter n equal 10 and P equal 0.9, right? So
Actually, here's my doubt. So,
yeah, okay.
So like in binomial distributions, we go successes. We are like in order. We do the experiment once. Either we have a success or a failure.
Yeah.
Then we do it again, and we have a success or failure. So in this way, we have a sequence of successful failures, right?
Yeah.
Okay. And then I have 10 options here. I conducted those Bernoulli trials 10 times, right? And out of those, I want suppose 8 successes. I want suppose here it is more than or equal to 8, but let's suppose I just want exactly 8, right?
Yeah.
Okay. So if I want exactly 8, what I will do is out of those 10 Bernoulli trials, there would be I should have selected 8 Bernoulli trials which would have probability of success, right? And that's how we get 10C8, right?
See, that's how you get 10C8, because you have how many? You have 10 screws basically. 5, 6, 7, 8, 9, 10.
10.
I am saying all the and what does X denote? X denote number of.
Ma'am,
yeah.
If I arrange the problem like a probability mass function, in the column there is 1 to 10 number of screws.
You don't even have to do all that.
In the row there is defective and non-defective. 0 and 1 denotes defective and non-defective. Then
even that is not required. I mean, see, you have basically X model number of non-defective screws, right? I'm saying number of non-defective screws.
And then I add the probability of
and I have to find probability X greater than equal to 8. This is what we have to find.
Okay.
And we know that here our X is nothing but a binomial distribution with n equal 10. You have 10 screws, and probability that each of these screws is non-defective is 0.9, right? So this is going to be probability X equal 8
plus probability X equal to 9.
X equal to 9
plus probability X equal to 10.
Yeah. So if you have to find probability X equal 8, it is going to be what? 10 choose 8, 0.9 to the power 8, 0.1 to the power.
Here's my problem, ma'am. So the specific problem is, suppose the first screw is defective and all other, suppose the first screw first is defective and second is defective, right?
Okay.
and all other are non-defective. This is the one case, right? Out of 10 choosing.
Here, okay, no. So here it is not like you are taking the first screw and it is defective. You are taking the second screw and it is defective. It is not like that. No, I mean,
I
out of
understand
10,
that out of 10, any two can be
any
defective. I
two
understand
can be
that.
defective.
Yeah, I understand that. I'm just giving an example of one such case. It is one
Yeah,
such
it
case
is-
out of 10
It is
C2.
possible. Yeah.
Now, other case would be if last two are defective.
Yeah.
Another, yeah, right.
Okay.
So my question is order are these two different things? Since screws are identical here in the question, screws are identical.
Order does not matter here, right?
Yeah, that's why we should not choose. Choosing does not make sense here. That's what I'm trying to say.
But when order does not matter, we should not look at permutation. We should look at combination, right? When permutation order matters, combination.
That's the case. That's the case. We should not look at combination. We should look at combination. Because order is not important.
Yeah.
So these two cases that I have said, the first, either first two are defective and second two are defective. These are the same cases. They does not make sense. There are no different cases, right?
So basically, you are choosing any two screw, right? It just you are selecting choose like two screws out of 10.
But what does that mean? All the screws are identical. There is only one case possible. Two screws are defective. That does make sense. But saying these two are defective, when you are choosing, you are saying these two are defective or these two are defective.
This
or
is
these two are defective.
number of ways to choose these two screws.
Yeah,
so what
which
is
two are defective? That's what it means. No?
10 choose 2 is what? It is 10 factorial by 2 factorial into 8 factorial, right? This is total number of ways to choose these two screws.
Ma'am, I'm trying to say is, when we say 10 choose 2, but why we are choosing? We are saying which two screws are defective. That matters to us, right?
That doesn't matter, no?
It doesn't matter here.
Any two can be.
That is why we are choosing here.
NC2, it is a count only. It is not an order. I think 10
order.
It is not an order. It is just a count.
See. It's not order. That's okay. It's
count.
not order. But how does
we are just counting that number?
Okay.
That could be any two of that. Any two of out of 10.
If all these at place of these 10 screws, they would have been 10 persons. I would not have raised this question, since choosing if you are choosing these two person or we are choosing other two person, it makes difference. But since screws are identical, which two you are choosing, it does not make sense.
That's why we are counting now. We are not ordering it.
How many ways are there to choose?
See, screws are identical. That is fine. But still you have 10 screws, right? I mean, you cannot say, since all the screws are identical, I can just take one and put one screw everywhere. It is not possible. Even though all the screws are identical, you have 10 different screws and you want to check, like you want to know how many ways you can select 2 defective screws from this collection.
And if we have
the
10
same
identical,
question in stat 1.
10 identical.
Same question. Yeah, I know. The same question is in stats 1. I had been there.
I know that, but
same question.
I'm
asking. In stat 1, I have solved it, and you can refer to that.
Okay, so that's not an explanation. I understand that.
No.
I'm saying
if you want to get the context of choosing or ordering,
I understand the concept. I understand the concept. Okay, here's a simple question. I have 10 identical balls. How many ways are there to choose 2 balls out of it? 10 identical.
That's it.
10
Oh, that's for different items. When they're different, there is only one way to choose.
No, it is 10 C2. If you have 10 balls and you are choosing 2 balls, it's 10 C2 ways. See, you can number the balls 1 to 10. Okay, you pick the first ball and the 10th ball. First ball and the 9th ball.
Different. Yes.
Okay, if you do make the combination, right, your first ball can be paired with 9 different with 9 other balls. Second ball will.
This does not actually
be identical, but the number in which you are taking all balls.
Ma'am, can you confirm it? Is choosing 2 balls out of 10 identical balls, is it 10 C2? Can you confirm it?
It is 10 C2. It is 10 C2.
Can
the order matters, right?
Ma'am, how can order matter?
can I explain it? If you have two boxes and you have
Yeah.
to choose, one box is full of 10 balls and another box is empty. You have to just simply put two balls out of those 10 and keep it in those empty bag. How you will do? There is only two way. There is only two way to choose 10C2.
Okay,
That's it.
can you list
So
those
any two can be
Any
chosen.
two can be.
And any
It
two
can
can be
be any
chosen.
two
There is
balls.
only one way to choose, na?
No, 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 no.
How one way to choose?
But
All that.
Ma'am, can I say?
Let me ask
please
you
do.
one question.
When you put your hand in the box to choose the ball, you have 10 options and you have to
Yes.
select two out of it. You will be confused. Although they are indicated, you will be confused. Which one to
matter which two I choose, I will get the same result.
Which
No.
result?
How are they different
Which-
options? They are the same options.
Which
See,
result?
see.
Which different result you are talking
Okay,
about?
sir.
Okay, just
Just a
Can
minute.
we-
leave this for leave this topic for now. Like this, you should have.
You take it at the end. You clear
Yeah.
the gentleman's
This
doubt,
you should
but,
have.
Actually,
Like,
I've gone through
This is a
internet.
very basic.
I've gone through lot of articles reading
Yeah.
about choosing from
See,
identical items.
you have already studied this permutation combination detail in stats 1, right? If you
Just
have,
one
if you
take.
still have a little doubt, please go back to the content and just see, clear your doubt. This
I
is
have
for
gone through that
stats
and
2
it
topic,
hasn't
right?
cleared my doubt. Please.
See, just if you want, there is only one way of having only one option, that you choose all the 10 balls, then there is only one way.
correct. If you choose all the 10 balls, then there is only one way. What he is telling is correct. You are choosing 2 balls out of 10. So there are 10 CR ways, 10 C2 ways. That's what he is he is trying to explain.
If you number all those balls,
I put
you
a
can
reference over
either
here.
select one
I
or
put
two.
a reference
Okay,
over here also
never
from
mind.
internet.
Never mind.
You have
Please,
put a
please
Okay.
take this discussion at the end.
yeah,
because-
you have put a reference over there, right? Okay, so I would suggest, please, can somebody go through it and just check. We will take this at the end. It will go on for so long. It is week 0 and we are here to discuss week 1, right? All this has been properly covered in stats 1.
Okay, no problem. You can clear his doubt at the end. Can we go back to the main agenda?
What was that?
So you are trying to discuss week 1.
Yeah, week 1. Yeah, I'm going to week 1 only.
Can we discuss week 1, the multivariable functions? The two variables are very much clear, but then the story after are little bit confusing. Can we clear that part, that is 1.4 onwards?
Yeah, just wait. Just give me a minute.
I guess we will be covering complete week 1, isn't it?
Okay, so in week 1, what all topics you have seen?
Up to week 4.
Not week.
Up to week 4 videos, 1.4.
Okay. In week 1, you will see these topics. So the first topic that will come is joint distribution. Second is marginal distribution. Then you will see conditional distribution. Then we have,
Multiple discrete random variables.
okay, first we have talked about all this. We have talked in first both 2 random variables and then some 3 random variables. Both we will see. And you have also marginalization. Right? So
And the last topic, factoring of joint PMF.
factoring of joint PMF. Okay. All right. Okay, so first let's see joint distribution, 2 random variables. Okay, so So far, we have been looking at only one random variable, but from here onwards, we will be dealing with multiple random variables. Now, if you have multiple random variables, how do you find the probabilities? That you should know. So this week, we are talking about only discrete random variable. We'll move to the continuous random variable later. Now, let's say you have two random variables, x and y, okay? Capital X and capital Y. And the range of x, let's say it is tx, and range of y, let's say it's noted by ty. Okay. So if I'm writing x, the range of x is tx. So what does it mean? It means whatever values your random variable x takes, this is going to be the set tx. Whatever values your random variable y takes, it is going to be ty. I'm writing for convenience that t1 belongs to tx and t2 belongs to ty. This is capital Y. Okay. So fxy, okay, fxy of x comma y. So if I write fxy of x comma y, this is nothing but probability that your random variable x takes the value small x and random variable y takes the value small y. So what is the probability that your x takes the value x and y takes the value y? This is what it means. Okay. And basically your fxy, sorry, this is capital Y. So this is basically fxy is a probability, right? So what is going to be the range of this? What is going to be the range?
0 to
of
1.
0 to 1. And its domain is tx cross ty. So whatever your range of x is and whatever range of y is, you find the Cartesian product, and that is going to be, the range is going to be 0, 1. So basically,
Can we call the domain sample space?
you can call the domain the sample space. Yeah, that's right. So since here I have written tx belongs to tx and t2 belongs to ty. Now, if I want to, let's say, write the joint distribution, so fxy, so x is taking the value t1 and y is taking the value t2. So this means that what is the probability that your x, random variable x, is taking the value t1 and your random variable y takes the value t2. So what is this probability? This is what we find using the joint PMF. For example, so our example has done there in the lecture. I'm taking that example. So let's say a fair coin is tossed twice. Okay, you have a fair coin. Can you mute yourself, Praveen? So you have a fair coin. You have, it is two outcome, head and tail, and you are tossing the coin twice. So basically, you are going to have 4 outcomes: head, tail, tail, head, head, tail, tail. Now I am defining my random variable to be xi. All right. So xi is given to be 1 if ith toss is head, and it is given to be 0 if it is tail. Now, so if I'm writing x1, since you have just you're tossing 2 coins, 2 fair coins. So I'm saying x1 is going to take the value 1 and 0 if the head appears on the first toss, and if the tail appears, I'm writing it to be 0. Similarly for x2. Let's say I want to find what is the probability fx1, x2, 0, 0. So what does it mean? fx1, x2, 0, 0. What does it mean?
Tail, tail.
Tail, tail. What is, like, if you're tossing 2 coins, you're
X1
tossing
equal
a
to
coin.
0.
Probability of x1 is equal to 0
Basically, probability x1 equals 0 and
and x2 is to
x2
0.
equal 0.
0.
So what is the probability that on the first toss, your tail appears, on the second toss, a tail appears? So it is nothing but 1 by 2 into 1 by 2, right? This is one way of doing it, like considering two different random variables, like on the first toss, what are your outcomes? On the second toss, what are your outcomes? So it's just one way of doing it. Even though if you had no idea about like how to deal with two random variables, still you would have done this problem. But just to show how you are going to use the two random variables, we are doing it in this fashion.
This 1 by
Okay.
2 into 1 by 2 is because they are independent, right?
Yeah, they are independent. Yeah. All right. So this is just one way of doing it. Similarly, if you, okay, now the second thing, this is just first I'm talking about two random variables here. So first we'll deal with two random variables, and this is what we mean by joint distribution. Next, what occurs is,
One doubt.
yeah.
So we know what are independent events, right?
We know
For
what
that.
are independent events, yeah.
Yeah, but specifically, what are independent variables? Like we are saying here, that's in the
Okay,
sense here we are
okay, wait. Independence, will start in week 2. It will come there. So let's talk about independence in the second week. Okay? In first week, we are not covering that part.
Okay.
Let's stick to whatever is done till in this week. Now, when we talk about marginal distribution, okay, so basically marginal PMF. Marginal PMF. PMF is probability mass function, right? So you have again two random variables, x1, x2, and these
Excuse
two
me, ma'am.
random, yeah.
You were about to explain another method of solving this same question, right?
No, I told this is just one way of doing it. Like
Okay,
even
okay.
though you did not know what is two random variables and all that, how to do it,
We
still
can use
you,
the concept of independent variable.
yeah, still you would have known,
Yeah.
okay, if I'm tossing a coin twice, we have 4 outcomes. What is the probability that 2 tail occurs? It is 1 by 4.
Okay. Yes,
Yeah.
ma'am.
So
But
in,
just,
in summary, for joint distribution, we can multiply the probabilities of the independent occurrence.
if they are independent, yeah,
If they are
independent, we'll see there is a relation between this joint PMF, marginal PMF, and conditional PMF. We'll look after that. Okay. So, all right, we have seen joint distribution, what it is. Now we have to, if we have two random variables and let's say they are jointly distributed. So it just, this is how we write it. So x1, I'm saying x1, x2 are jointly distributed. So x1, x2 is if x1, x12, xy, x1, x2, okay?
Does it mean they are jointly distributed?
Jointly distributed, this is what it means. It means you have joint distribution. What did you see? Like the first random variable x1 takes a particular value, second random variable takes a particular value. What is the distribution?
You can find the probability for them jointly. That means
you find the probability for them, basically. Yeah.
Jointly we can find the probability. Right?
Yeah.
So is it possible that two random variables associated with one experiment are not jointly distributed? Is that also possible?
It is possible.
Can you give an example of that?
Right now.
Yeah, means some random variables which are not like, which can, for we cannot find joint distribution.
Okay. So if you define some random variable in such a way, so like if you look at this example only, so what does this example says? Like you had to find what is the probability that you have the first toss you are going to get tail, and the second toss you're going to get tail.
Ma'am, instead of mentioning 0, 0, we could also have used head tail notation as well. That would not have made any difference, I guess.
Yeah, that would not have made any difference.
Random, but then we can't call it random variable. Random variables have range of real numbers, right?
Random variables have
Okay,
range
that's
of
why
real
we are
numbers.
assigning a number. Okay.
Yeah, random variables have range of real numbers, huh?
Random variables have range of real numbers.
Okay, got it. We are just assigning a real number to it for the sake
Yeah.
of
Yeah,
calculation that may
like
arise.
like whenever you define a random variable, you also define what is going to be the range of that random variable. So all this range belongs to our.
Okay, got it.
Okay, when can we not define?
Ma'am, in a word problem, if it is mentioned that head and tail, then it is our liability to assign a real number to particular event, I guess.
Sorry, can you repeat?
If in a word problem, it is, for example, in this question itself, the main point was that whether the outcome is head or a tail, right? And it is us on our part that we are assigning 0 or 1, isn't it?
Yeah, it is just, like here we are defining the random variable in such a way, like this. Look at this xi here. So ith toss head, it means I'm defining it 1. So it means if you put I to be 1, so first toss, if it comes to be head, I'm just giving that the value 1. If it comes to be tail, we are giving the value 0.
Okay,
this is how we are defining it.
We are defining it. Is not mentioned in the question, right? In the question, it is only mentioned that it is head or a tail.
Oh, no. I think it is mentioned in the question itself. I mean, it is mentioned in the question that this is how the random variable is defined. Till here,
You're talking about random variable. Explain the range also.
Till here, it is already defined in this was the question. And you had to find fx1, 2 of 0, 0.
I'm asking this question because there is a reason behind it. Because whether we assign it a real number or not, it is not going to make any changes in probability. It is still going to be half, whether it is 1 or 0.
It is still going to be half. Yeah.
So just for the sake of definition, we do that, right?
It is like, see, this was an easier example, so it's fine. But if you come up with a very complicated word problem, then every time writing the outcomes, it's quite difficult. So that is why, for our convenience, like we give a number, we assign a number to the variable.
Yeah, suppose we want to find the expectation or the variance, then also number will be important, right? Giving a number will be important. If we want to find the expectation or variance of the random variable, then giving a number would be important for that. You cannot find the expectation or variance of a variable which does not have real values.
Exactly.
Also, like if you look at the second example, that is, I'm not sure how many of you have watched the lecture. So there is another example given after, like this is the first example that was discussed. So if you look at the second example, there you have a random 2-digit number. So there it's difficult to write down all the possibilities. So once you assign the values, it's become a little easy.
Exactly, ma'am.
So yeah, I would suggest don't just rely on the live session here. I would please go through each of the lectures. Okay. So live sessions are mostly for your doubt clearing things. If you face any difficulty in understanding the lecture or solving problems. So I will just give a brief description of what all is there in the lecture. But please
It's
go
just
and
that
watch the
this week we had week 0 also. So
yeah.
that's why.
We'll give a brief.
Further, we will take care of that.
Yeah. We'll give a brief introduction what is in the lecture, but not in detail. Okay.
We were saying variables, if it's possible, if they cannot be jointly distributed. As an example.
We'll have to define it.
I think in the lecture also they have
sorry.
Example.
May I ask some question, please?
Unit place.
Excuse me, ma'am.
Yeah, just hold on. Who was saying unit place something?
Yeah. Unit place. It has been mentioned as 0, and then the tens place mod of 4, something like that. So it is interdependent. So it is not fully independent.
I think we can write the joint distribution of any two random variables. I think that's what I think. I may be wrong, but we can write the joint.
I want to ask one basic question.
Yes, we will apply conditional probability in that case, I guess.
See,
Yeah,
suppose
okay.
we have x1 here, right? It's a random variable.
Sorry,
And-
we have
Yeah. So there are two random variables, x1 and x2, right?
x1 and x2. Yeah.
Yeah. So if x1 takes any value, it takes 1, 0, 5, whatever it takes.
Now, okay. Okay.
That is just an event, probability sense, right?
Hmm.
That is just an event. Similarly, if x2 takes any value, that is also just an event. We are trying to find the probability of that event.
Yeah, right.
So when we say they take both of these values together, what we are saying is that we are saying intersection of those events.
Yeah, intersection of those two events.
So if we are taking any two random variables, we can find definitely
We can
intersection.
find intersection.
So definitely any two random variables can be jointly distributed.
Any two random variables can be jointly distributed.
Since we can definitely find the intersection, it may come 5, it may be equal to 0, but we can definitely find it.
Yeah.
Yeah, that's what I said. Now we will have to apply conditional probability or a multiplication rule depending upon the situation, whether the events are independent or dependent.
Yeah.
I think
Well, it has one random it has two tosses. The coin is tossed two times, right? That's why it has two random
The same
variables.
example. Okay.
If the coin has been tossed one time, it has one random variable.
It would have been one random variable.
When we
And
say
if the
that
coin is
two
tossed three
variables,
times, it has three random variables, right?
when we say that two
It's
variables
like
are
this.
jointly distributed,
Even for
speak
single
one.
toes, we can define more random variables,
Speak
right?
one by one. Everybody is speaking at the same time. It's difficult to keep track.
Even for the single toes, we can define more than one like random variable.
Even for the single toss, okay. Can you define once? Can you define?
Yeah, one random variable equal to number of heads and another equal to number of tails in that toss. So we can define its tails and number of heads.
But you're talking about just one toss.
Yeah, even in that, it's just part of definition. No, define it.
I think as long as it will satisfy.
I think the range, when the ranges are in the equal, then we can define it.
And is it true what he is saying that in a single toss we can define two random variables? One for head and one for tail.
He's okay. It is said that you have just one toss. So either it can come head or it can come tail. So okay, can you define me define two random variables here?
I think we can like both
You
of
just have
them
one
will
toss.
be.
You just have one toss. So one toss basically it means one outcome. So what you're going to define?
We can define like x1 equal to number of heads
and
x2 equal to number of tails. So if head comes, x1 is 1 and x2 is 0. And if tails comes, x2 is, we can define it this way.
Could I speak?
You can just take random variable x, right? Random variable x is 1. If head comes, it is 0 otherwise.
Yes, exactly. Where the question of number of heads comes here. Nowhere.
Yeah, he is saying that we can define two random variables in a single toss. And how are we going to define two random variables for a single toss? He said one for head and one for tail. How they are connected?
You cannot say that x1 equal 1 if it is head, otherwise 0, and x2 equal 0 if it is head, 1 if it is tail. I mean,
could I speak,
ma'am?
Please move ahead from this. We'll
Ma'am, please let us go through those five points, ma'am, because already.
What 5 points? Okay, yeah.
That joint distribution, you are
It's already
continuing.
45 minutes are over.
Yes, ma'am. Yes, ma'am. So after this five points, then we can go for these type of discussions. Sorry to say this.
Okay, so when you have to find what we are saying is you have two random variables, and those two random variables we are saying are jointly distributed, and the probability is given by fx1, x2, x1, x2. Now, when we have to find the marginal PMF of these random variables, so marginal means what you attain on the margin. So if I have to find marginal distribution of x1, so I will write f x1 of t, okay? And to find the marginal, you will sum the joint. So what is joint? Joint is f x1 x2 of t comma, let's write it t1, okay?
T
So
dash,
t1
email
comma,
at T dash.
no, let's write it t1, x1 to be t1 and x2 to be t2, okay? So to find the marginal of x1, what you will do is, you will do the sum of the joint, you will fix your x and vary your y. I will give you one example here. So t2 belongs to basically ty. And if you have to find the marginal PMF of y, x2, so fx2 of t2, to find the marginal of x2, you will do sum of joint, where you will vary, you will fix your x2 and vary your x1. So t1 belongs to, so this is not, this is x2 and this is,
it's like law of total probability, na ma'am?
this is like law of total probability. Okay, so what is law of total probability?
We are like I have to find like
Let's say
probability.
I have let's say I have to find probability of, you have two events A and B.
Yeah.
Okay.
If I have to find probability of A, what I
Okay.
do is I find probability of A if B has occurred and into
probability of B.
And
Plus
then I find probability of A if B
given
has
B
not occurred.
complement into probability of B complement.
B complement.
Right?
It's like that, na, but their values. We are finding the probability of first variable for different values of second variable.
Let me give you one example. Okay, I will give a very basic example.
Ma'am, the word marginal comes here from contingency table, right?
Marginal comes here from the contingency table. Okay, what do you do in contingency table?
That is why
contingency table is for categorical variables, na?
Categorical variable, right?
It's not valid here, I think.
Let me give one example. So you have two random variables. Okay, you have two random variable x1, x2, and let's say x1 is taking the value just 1 and 2. I'm just giving one example. And x2 is also taking the value 1, 2. Let's say this, there you have to write what is the probability that x1 equal 1 and x2 equal 1. Okay, this is what it means. So here it will be, what is the probability that x1 equal 2 and x2 equal 1. Here similarly, probability x1 equal 1 and x2 equal 2. Here probability x1 equal 2 and x2 equal 2. So let's say I'm writing everything to be 1 by 4. Let's say this is also 1 by 4, 1 by 4,
equally
and 1 by 4.
events.
Okay, let's say everything is 1 by 4.
Okay.
Now, if I have to find the marginal of, let's say, x1, all right. So I will find, now let's add the rows and the column. I will write the marginal of, so I am fixing my x2. So x2 of x2 and here fx1 of x1. So whatever we will get here. So if I have to find, let's say, margin of x1, I will sum this row, sum this column. So 1 by 4 plus 1 by 4.
1 by 2.
So 1 by 2. This is also 1 by 2. This is also 1 by 2. And this is also 1 by 2. So what we are doing here is, if I have to find fx1 of 1. Okay. So x1 taking the value 1. This probability. So I am fixing this x1 equal 1 and adding the joint probabilities over x2, right? So what is 1 by 4? It is a joint probability. What is 1 by 4? It is a joint probability. But I have fixed this column, and this column is like I'm fixing my x1. So whenever you have to find fx1 of 1, right? So whatever subscript you have, that variable you will fix. Okay. So here.
And we have to add that x2 equals to 1 and x2 equals to 2. Am I right, ma'am?
Yes, that is right. So you will fix your x1. I mean, so x1 here is 1. So you will fix you'll fix x1 to be 1 and then add the joint probabilities for x2, and x2 is taking the value both 1 and 2. So you will have to add the values that is there in this column. This is what has been written here. Okay. Now if we, it's clear. Now if we have to, find fx2, just wait. Now if we have to find fx2 of 2, then what will you do?
Fix x2 is equal to 2.
Sorry.
I mean fix x2.
Fix x2 to be, fix x2, that is 2, and add the joint PMF over x1. You will vary your x1. So basically these two. So 1 by 4 plus 1 by 4. This is 1 by, and this is what is written here.
Ma'am, this fx1 of 1, like we are finding the marginal PMF of x1 for value 1, right?
Yeah.
Will this be equal to probability of x1 equal to 1?
Yeah, it is same. This is also called, this is also probability only.
This first one is probability of x1 equal to 1.
Probability, what is the probability? Like if two random variables are jointly distributed, then what I've said is that your random variable x1 is taking the value 1, 2, and x2 is taking the value 1, 2. Then fx1 of 1 means what is the probability that your random variable x1 is taking the value 1. That's it. This is what it means.
So like in joint, we are trying to mix two variables together. In marginal, we are trying to bring them out again.
Yeah.
We are separating their distributions again, right?
Yeah.
Ma'am, T1 and T2 here are probabilities, right?
No, T1 and T2 are the values your random variable takes. So if
you are talking about range, ma'am, I guess.
If I have written fx1, x2, right? T1, comma T2.
Yes, ma'am.
Then what does this mean is, what is the probability that your random variable x1 is taking the value T1 and your random variable x2 is taking the value T2?
Okay.
So basically T1 belongs to the range of x1.
Yes,
T2 belongs to the range of
x2. Yes, ma'am, got it. It is the range of the function.
Range of the function. Yeah.
Yes, ma'am. It can take any value within the range.
It can take any value within the range. Yeah. So this is,
now it's clear.
Yeah. So this is what about the marginal. Now, if you are given the joint distribution, the marginal will be unique. So one statement here is like, given the joint distribution, the marginal is unique.
Other one is also true, right? We have separate distributions for x1 and x2, and joint is also unique.
Okay, you're saying separate distribution for
like marginal distributions. So we have marginal distributions for x1 and x2. Then joint is also unique, no?
No. That is what is wrong. So if you have two marginal that are unique, so let's say I have two random variable x1 and x2. Okay, so you have x1, you have x2, and taking the value 0, it's taking the value 1, taking the value 0, it's taking the value 1. First I'm saying it is 1 by 4, it is 1 by 4, 1 by 4, and 1 by 4. And here it is fx2 of T2, and here it is fx1 of T1. You get here 1 by 2, 1 by 2, 1 by 2, and 1 by 2. All right. Now I'm giving you another joint distribution. So it is x, it is y. and it is again taking the value 0, taking the value 1, 0, and 1. And this is, I'm saying it is 0, it is 1 by 2 minus x. Oh, sorry. This is x. 2 minus x. This is x. Now, if you find, let's write it x1, x2 only. So x2 of t2 and fx1 of t1. So again, if you see, the marginals are all 1 by 2, right? Marginals are all 1 by 2. But are the joint distribution same?
No.
No. So given the marginal, unique marginal, you can have two different or more than two different joint distribution. But if you are given the joint distribution, the marginal is always unique. So it is not both ways. It is just one-sided. So if you are given the joint distribution, you can always find the marginal, and that marginal will be unique. But if I have given you a marginal PMF, you cannot find the joint distribution.
Ma'am, can you tell me the physical significance of the
Sorry?
marginal? Can you tell me the practical significance of marginal?
You will
marginal
see. There are applications later. There you will see. I will tell you.
And one doubt.
Yeah.
So what is the difference between distribution of variable x1 and marginal distribution of x1?
It is same thing. If I'm saying fx1, it means you are talking about distribution of x1. Even though you're just saying it is a marginal distribution, basically you're talking about what is the distribution of the random variable x1.
So what we are saying is, given the distribution of two variables x1
if you
and
have,
x2, we can have different joint distributions.
You can have different joint distributions. Yeah. Like if I would have just given you that fx1 of 0 gives 1 by 2, fx2 of fx1 of 1 is 1 by 2, right? Then I cannot say that it is going to only have one joint distribution, because you see here, right? You can put any x here between 0 to 1. So here x will always lie between 0 to 1 because of probability. You put any x between 0 to 1, you will get, you get different probabilities here. So both two are same only in the case when x equal 1 by 4.
So we cannot find joint distribution from the distribution of separate distributions of variable x1 and x2. We cannot find that.
Yeah.
However, we can find the separate distribution from marginal from joint distribution.
You can, it's not separate distribution. Like if you already have a joint distribution, you're talking about joint distribution here, means you have two random variables and they are jointly distributed. Then from there you will find a unique marginal, right? If I'm giving you this joint distribution table, then this marginal that you will get is unique. I cannot say that this fx1 of 1 is going to be something else. It is definitely from this table. It is 1 by 2. It cannot be anything else. So it is unique.
So we can find like this marginal distribution from joint, but vice versa we cannot do, right?
Yeah, vice versa we cannot do it in a unique way.
In a unique.
Yeah.
Suppose if you are given that marginals are given and you have said that the two random variables are independent, then we can find a
you can find
unique joint by multiplying the marginal probability.
Yeah, yes.
By multiplying the
we'll see. Yeah, it is true. It is same as like if you have two events A and B, then their intersection will give you probability of A to probability of B.
Multiplying the marginals, you can get the joint probability.
multiplying, yeah, if it is independent, you multiply the marginal, you can get the joint distribution.
So we can say
Yeah.
when variables are independent, then joint is also unique for marginal.
Then joint is also unique. Yeah, we can say that.
Ma'am, we can find the joint by conditional probability.
Sorry, we can find the joint
By conditional.
Conditional. We'll see. Right now we have only seen joint and marginal. We'll see.
So that method we can find the joint.
That using the conditional and marginal, you can find the joint. There is a way.
Yes.
We'll look at it. Sorry, your voice is not clear. Can you repeat?
Ma'am, in a summary, what I conclude is that different set of events may give same probability.
Different set of events may give same probability. A different set of events.
Because different set of events would have different probability, and when we sum them, we will get the same probability. For example, we are tossing a coin. Necessarily does not mean that the sequence in which we get head and tail would be same. But when we sum them over, eventually it will come out that the probability is 0.5 of head and 0.5 of tails. Isn't that what we are implying here?
That's very vague, actually. It's the way you are.
It's
ambiguous. The statement is quite set of events is like referring to anything.
Of course, we are dealing with two events only.
So what you can take it from here is like, if you know the joint distribution, okay, if you know the joint distribution, you can always find the marginal in a unique way. Okay.
But vice versa is not true.
But vice versa is not true. Like if I give you the marginal, it is not possible to find the joint distribution in a unique way.
Altogether, a different set of events could have resulted in the same marginal.
Yeah.
Exactly. That was what I was saying.
Yeah.
Okay.
So after this, we have conditional distribution.
Ma'am, can we have the physical significance of the marginal? Why we need
Yeah,
it?
there are examples. I just what I told. There are examples that we'll see.
I guess we have completed lecture on that. No? Application.
Correct me if I'm wrong. We may have sometimes we may have the joint distribution, but we may have to calculate the marginal one. We may not have the marginal. So by having the joint, we may come to the marginal by this, in a certain experiment. We may have the joint distribution, and by knowing the joint distribution, we can calculate the marginals, which may not be so obvious. Marginals may not be so obvious in certain experiments, if I'm not wrong.
Yeah, like some places it is possible that you know the conditional distribution, you know the marginal, and then from if you know any of these two, you can find the joint. Some places you may know just the joint distribution. If you know the joint, you can find the marginal, and then you can find the conditional. So we'll look at it. There are examples. So okay, we just saw joint and marginal, and now we will look at the conditional distribution. Okay. So, okay, there is a, okay, let's say we have again two random variable x1, x2. They are jointly distributed x1, x2, t1, t2. Right? So if I'm writing probability x1 equal t1, or let's not write this. Let's write f of x1 given x2 equal t2 of t1. Okay. So what we can write it this as? This is nothing but probability that x1 equal t1 and x2 equal t2 divided by probability that x2 equal
x2 equals to t2.
T2. Okay. So this is how you write the
Actually,
conditional.
then in the lecture, sir mentioned formula. That conditional is equal to joined by marginal.
Yeah. So basically, what is this? This is conditional, right? Conditional. What is this? This is
Joint.
joint. So conditional is, and what is this? This is marginal.
Marginal.
So conditional equal joint divided by marginal, or you can say joint equal conditional times marginal. All right. So here it was x2 equal t2. You can also have like you can write the same expression in two different ways. So you can write fx1 x2 x1 comma t1 comma t2 to be equal to f x1 given x2 equal t2 of t2 times fx2 of t2, and this is also same as, this is equivalent to
Even ma'am.
x2.
They should be even.
Sorry. Oh yeah.
T1.
It is t1. Right.
It's T1.
Yes. So this you can also write as fx2 given x1 equal t1 of t2 into fx1 of
T1.
t1. Okay. So you can write the joint distribution in two different ways. If you have two random variables. So like I will give a very small example here. So let's say this is x1, this is x2, this is 0, 1, 2, and x2 is taking 0, 1. Okay. Let's say this probability is 1 by 4, this is 1 by 8, 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 this is 1 by 4. All right. So okay, so now you have to define the range. So what is the range of, if x1 is given to be 0, what is the range of x2?
0, 1.
X2 is 0, 1, right? Similarly, if x2 is given to be 1, what is the range of x1?
0, 1, 2.
0, 1, 2.
0, 1, 2. So this is clear to you, how to find the range. So basically, I'm fixing my x1 equals 0. I'm fixing this column, and I'm seeing what all the values x2 is taking. So it is 0, 1. Here I am fixing x2 to be 1, and I'm seeing what all values y is taking, x1 is taking. So it is 0, 1, 2, right? That is all it is there. All right. So from this table, can you find what is the probability that your x2 given x1 equal to 0 of 0?
3 by 16.
1 by 2.
Sorry?
1 by 2.
1 by 2. Okay.
3 by 8. 3 by 8.
3 by
1
8.
by 4 into
3 by 8.
Okay.
3 by 8.
3 by 8. Any other answer?
3 by 8, ma'am.
Okay. Any other answer?
1 by 2.
Ma'am,
1 by
cannot
2.
understand the notation clearly.
1 by 4.
1 by 4. Okay.
2 by 3.
1 by 4, I guess, ma'am.
Okay. We have 4 answers here.
1 by 3.
1 by 3. 5 answers. Okay. Anything else?
1 second.
Okay.
We have to find probability, not a joint PMF, I guess. That's why 1 by 4 I'm saying.
Okay.
2 by 3. 2 by 3 is it?
2 by 3.
We have 5 answers here. Now
by 3.
what? Okay, 2 by 3.
I take my 1 by 2 back.
Okay.
No, it will be
All right.
it will be 2 by 3, ma'am. 2 by 3.
Okay, okay. So now you got it. Why is it 2 by 3?
2 by
So
3, 2
basically
by
it is probability that x1 equals 0 and x2 equals 0 divided by probability that x2 equals 0, right? So what is the probability that
Okay.
x1 equals 0 and x2 equals 0? It is
1 by
4.
4 upon.
And what is the probability that x2 equals 0?
1 by 4 plus 1 by 8 plus 1 by 8.
3 by
1 by 4 by 3 by 8.
3 by
3 by
8.
8.
So basically it is 2 by 3.
2 by 3.
So be careful when you have to find the conditional. Many a time what happens is we just find the joint and then leave it. But don't forget to divide it by the marginal.
Marginal.
Ma'am, in the denominator, shouldn't it be x1 equal to 0? Is it x2 equal to 0?
Sorry. Oh, wait. Did I do something wrong?
x1 equals to 0.
Okay.
X1, denominator x1 equal to 0.
In this case, but actually it should be x1 equal to 0.
Ma'am, can you repeat please how fx2 by x1 is equal to 0, and then you derive p of x1 is equal to 0, comma x2 is equal to 0 by.
So what is meant by f x2 given x1 equals 0 of 0? It means you have to find the probability that this is equivalent of saying probability that your x1 equals 0, sorry, your x2 equals 0 given this x1 equal 0, right? So we just saw the formula here. Right? So what does it mean? So if you are given the conditional, if you have to find the conditional probability, so this is nothing but your conditional distribution, right? Conditional probability you find if you have seen in stats 1. So if you have two events A and B, so probability that your A given B is what? This is nothing but probability A
intersection B upon
divided by probability
of B.
The same thing we are doing here. Now, instead of A, B, you have the two random variable x2 and x1. So in the numerator, you will write the joint distribution. So intersection is nothing but the joint distribution. So you write x1 equals 0, comma x2 equals 0 divided by the second one. So this is nothing but probability x1 equals 0.
The joint distribution are never disjoint.
What joint distribution are?
The events of the joint distribution are always mutually inclusive. Then only the intersection will yield some result.
We are talking about okay, it is not necessary that all of this has to be some probability. It is possible that in the table you can have 0. It is all right.
The summation would never be 0.
Oh, not summation. I mean some probability. It is possible that they can be 0. I'm saying.
Okay.
All right. Also, there is one more thing that you should take care of. That
one doubt.
Okay, wait. So overall marginal, the sum should come out to be 1. I mean, if here x1 is taking the value 0, 1, so your fx1 of 0 plus fx1 of 1 should be equal to 1. Similarly, fx2 of 0 plus fx2 of 1 should be equal to 1. So all of this should sum up to 1. This you should take care.
I have a small doubt here.
Yeah.
Can any column or row here could have 0, like the total, or what can I say, the joint?
Yeah, so joint can be 0. So let's say you had this here, right? I mean, this
Marginal.
was the joint distribution given to you.
Mhm.
Okay, so I can, instead of this, I can also say that I can also give you the joint distribution as 0, 1, 2. Say 1, 2. I'm saying this is taking the value 1 by 8, 1 by 8, 0. One by 4, 1 by 4. Okay. This is possible. So what should happen is, like, all this should sum up to 1 because it is a probability, right? So if you look at the properties of probability, what do you see? You say that probabilities will lie between 0 to 1, and the second property that you say is sum over
Sum of all entries.
sum of
All events. Probabilities of all events
probabilities
have
of
to
all
be
the
one.
event, all event should be equal to 1. So here you have, like, you have taken all the possibilities of x1, you have taken all the possibilities of x2. So this probability should add up to 1. Okay. So it is possible that so here what is happening is your x1 taking the value 2 and x2 taking the value 1 is 0. Can you mute yourself?
So given x1 equal to 2, x2 has only one value, which is the range of x2 is only 2.
Given, sorry, can you repeat? Given x2
Given x1 equal to 1, given
okay.
x1 equal to 2, range of x2 is only 2.
Not 2.
Given x1 equal 1 or given x1 equal
x1 equal to 2. x1 equal to 2. Range of x2 is only 2.
Oh, 0, 1.
Range has to be a probability,
0,
right?
1.
Range is only 2. Given x1 equal to 2.
Given x1 equal to range of x2 is 2, right? That is right.
Yes.
It's 1. How is it 2, ma'am? 1, it can also take the value 1. Maybe
Okay,
with probability 0.
Yeah, so it is not, I mean, if something is probability 0, you don't even have to add it in the range, no?
One more doubt here, ma'am. So, like, we have, suppose x1 equal to 1.
We have x1 equal 1, okay? It's the same example?
Yeah, the same example.
Okay.
We have x1 equal to 1.
Okay.
And then the range of x2 will be 1, 2.
1,
right?
2, yeah.
Yes, yes.
So can you write that down, please? I have a question to ask, sir.
Given x1 equal 1,
The
the
range
range
is
of x2
is 1, 2.
1, 2. Yeah.
So
okay.
Now, as in the sense like we used to do, looking just at the restricted sample space now, can we find the probability of like x2 equal to 1, not by going the definition, but
x2
by
equal
1 by 8.
1 is
1 by 8.
x2 equal 1 is 1 by 8 plus 1 by 8, 1 by 4.
Sorry, 1 by 8 plus 1 by 8.
x2 equal to 1 is 1 by no.
Given x1 is equal to 1, he's saying, ma'am.
Oh, given x1 equal 1, you are saying.
Yeah.
That
can we find that from conditional restricted sample space only?
Given
Used
x1
to do
given x1 equal 1, probability of x2 equal 1 is 1 by 8. Yeah, that is right.
How come, ma'am? I didn't understand. That's joint probability. No? That's just joint probability.
1 by 3.
That is,
but you are already restricting it.
What you are citing is very very easy thing. What we do is that we fix one event and let the other events vary.
Yeah.
And then we add up and we talk about its probability.
Given
you are specifying a particular coordinator that is always given, I guess.
So you are saying you are already fixing this x2 to be 1. Then if you are already fixing your x1 to be 1, you can see that the probability with which x2 will take the value 1 is just 1 by 8.
Yes.
And okay, let's say it's 1 by 8, and probability with which it will take the value 2 is
1 by 4.
Again 1 by 4.
Then they should come. Then they should add up to 1, na?
Why should they add up to 1?
X2 can take only 2 values now in the restricted sample space.
X2 can take only two values.
1 and 2. So they are like, it's a
Ma'am, he said
it's a probability
about
space,
conditional
na?
probability.
Yeah, but
Sorry?
conditional probability space is also
Yes,
probability
so,
space.
So, hello. So
Yeah.
you are, ma'am, if you are said joint probability, but he asking about conditional probability. So answer would be on 2 by 3. First, when x1 is to 1, given that x2 is to 1,
Exactly.
it
You
would
just
be,
do not need to add.
it would be 1 by 8 by 3 by 8.
Sorry, can you repeat? Can you repeat?
Probability x1 is to 1, given that x2 equals to 1, it would be, I think, 1 by 8 divided by.
Okay, first of all, what are we trying to find? First tell me.
Conditional
This probability that
Okay,
x1
which probability?
that
Given x1 is equal to 1, what is the probability of x2 being 1? X2 being 1. It is 1 by 8.
All right. We have to find this probability.
1.
Yes.
X2 being 1.
Okay,
He is also
1.
specifying x2 being 1.
X2 equal 1. Okay.
It
So
is 1
this
by 8.
No, ma'am.
No. It is 1 by 8
1
plus
by 3, 1
divided
by
by, you have to divide. So it will be 3 by 8.
3 by 8, yes.
1 by 3.
It is
1 by 3. Yes. Earlier you said that is
yeah.
And x2 equal to 2 is 2 by 3.
X2 equal to is 1 by 4 divided by 3 by 8.
That is 2 by 3. So the sum is equal to 1.
Yes,
Now the sum is equal to 1.
Condition, if we put the condition that x1 equal to 1, then the addition of both these probabilities equal to 1. So
Then
the sum
addition
of
of
the conditionals.
Yeah, so like you're fixing your x1 and then you're finding the probability of x2. Then it should come up to 1. Like whatever values x2 is taking, you'll have to add everything. So basically probability x2 equal 1 given x1 equal 1 plus probability x2 equal 2 given x1 equal 1 will come out to be 1. So if x2 was taking more values, 3, 4 and so on, so everything should come up to 1.
And if x2 would have been uniformly distributed.
Sorry, if x2 has been
uniformly distributed,
okay,
then we could have been able to find the probability only looking at the restricted sample space. Like
you're saying x2 is uniformly distributed. So here x2 is taking the value 1, 2.
Yeah.
So basically you're saying probability x2 equal 1 is 1 by 2, probability x2 equal 2 is 1 by 2.
Yeah.
Okay.
So I'm saying when x1 is equal to 1.
When x1 equal 1, okay.
And we can say that x2, the range of x2 is 1, 2, right?
The range of x2 is 1, 2, right?
So the probability of x2 taking 1, then we do not have to go to the definition. We can definitely say it is equal to 1 by 2.
Probability of
x2 equal to 1.
Equal 1.
Is it, when x1 is given that x1 is equal to 1.
Given that x1 equal 1.
Yeah, this is equal to 1 by 2 na, because it is uniformly distributed.
No, your x2 is uniformly distributed. But when you're writing that x1 and x2, like x1 is 1 and then what is the probability of x2 equal 1?
1 by 2 plus 1.
Uniformly distributed means the marginals are all equal.
Marginals are
all equal. That does not mean that the joints are same.
equal. So basically you're saying when you sum this, it should come out to be 1 by 2. And when you sum this, it should come out to be 1 by 2. Right?
Yes.
Marginals are equal.
I can have here 1 by 4 and I can have here 0. Then you see here that the marginal, like probability x2 equal 1 is coming out to be 1 by 2. x2 equal 2 is also coming out to be 1 by 2. But does this mean that all the marginals join that you have are equal? It is not there.
No, it can't be.
So in the we have x2 is like uniformly distributed, and then we restrict the value of x1. So the values then that it take, then why is it not uniformly distributed in that? Like, should be uniformly distributed over those values also.
Why should it be uniformly distributed? You are talking about given x1 equal 1, what is the probability of x2 equal 1? And you're saying it just x2 is uniformly distributed. So here, so you have one example here, right? So this is 1 by 8, this is 1 by 8, this is 1 by 4, it is 1 by 4.
Hello, ma'am.
Yeah.
It can be possible a square matrix for square matrix.
Square
Like,
matrix.
it
Okay.
can be because
Okay, let's take 2 by 2.
yes, 2 by 2. I think otherwise it can't be because one side is greater than.
So you have x1, you have x2. I'm saying, let's say this is taking 1, this is taking 2, 1 and 2. And you are saying that fx2 of t2 is
1 by
uniformly
2.
distributed. So this is 1 by 2, this is 1 by 2. Okay.
Yes, ma'am.
So I just want this to be 1 by 2, this to be 1 by 2. So what all we can write? We can write this as, let's say, 1 by 4. If I write 1 by 4, okay, let's write it as
1 by 8 plus
1 by 8 plus, what it will be?
3 by 8, 1 by
3 by 8.
3 by 8. Okay. Let's write as 1 by 4 or 1 by 4.
1 by 4.
Is it adding up to 1? It is adding up to 1, right? Yes. Okay. So here x2, which is taking, we are saying that it is uniformly distributed. So it is 1 by 2, it is 1 by 2. Now, given x1 equal 1, what is the probability that x2 equal 1? Okay. So this is 1 by 8.
1 by 8.
1 by 3, 1 by 3.
3 by 8. 1 by 3.
3
1
by
by
8.
3 by 8.
1 by 3.
1 by 3.
Now, given x2 equal, or given x1 equal 1, probability
3.
x2 equal to 2.
3 by 8. 2 by 3.
2 by 3.
2 by
2 by 3. So are you getting this to be uniformly distributed?
No.
Put it, ma'am. It's not necessary.
No, right? You're just saying your marginal is uniformly distributed. Your x2 is uniformly distributed. But you cannot expect that if you are fixing given one random variable, the conditional will also come out to be same. I mean 1 by 2, 1 by 2. It is not necessary.
If both are uniformly distributed,
Like
x1,
it's same as given a marginal, the joint is not unique, right? We have seen that. Given marginal,
yes.
the joint is not unique, and that is why you are getting different here.
Okay.
Because you can have, given this marginal, you can have many different joint distribution. I could have 1 by 4, 1 by 4, 1 by 4, 1 by 4.
Yes.
Ma'am, can you please explain the second probability? x2 is equal to 2 given that x1 is equal to 1.
Given x1 equal 1. So basically this column, okay? And what is the probability that x2 equal 2? So it is basically 1 by 4 divided by 3 by 8.
How the 3 by 8 will include money actually?
1 by 4.
Ma'am, for x1 we have to look up vertical values. For x2 we have to look up horizontal values, ma'am.
See, okay, let's see. This is what you have to find. And this is what? This is x2 equal to, comma, x1 equal 1 divided by probability x1 equal 1, right? So this is joint distribution. So x2 equal 2 and x1 equal 1, this is 1 by 4. All right. But
okay,
probability x1 equal 1, this you have to add this
Write it over there, ma'am. That will be easier for them to understand.
x1 equal to 1, that means I have to add 1 by 8 plus 1 by
Yes,
4.
1 by 4. Yes. Yes.
Okay. Now
Okay. Now.
So we have to take the marginal values, ma'am.
Marginal. This is marginal.
Yeah, 1 by 8 plus 1 by 4 is equal to marginal values.
Marginal of
x1 is equal to 1.
Yeah.
Okay.
If you write it there once for our reference also, it will be easier.
Right. What?
Yeah.
If you write the full table, means including the
not full table. What they asked kind of.
They just asked this only.
P of x2 is equal to
F of
put an
x1
equal to and put the numbers also over there. That will be easier for reference. The respective numbers from the table.
Excuse me,
Okay.
ma'am.
Yeah.
Ma'am, I have a doubt in conditional probability from activity. So, can I go ahead and ask the doubt?
You have doubt from conditional probability.
Yeah.
Okay. Can you tell me the question number?
Ma'am, it's AQ 1.3.
Okay.
The first one.
Question number 1. Okay. Let me see. I will share that screen. Not find it.
Ma'am, you are not audible.
Yeah, just wait. This is
Oh.
Yeah, just let me see where is the problem. I cannot find it. Question. Yeah, this one, right? Which problem?
Ma'am, the first one. Yeah, the first one.
Okay. So how many of you have doubt in the first problem? Alright. So what does it say? It says from a well shuffled deck of 52 cards, 4 cards are selected at random. Okay. And we are defining 2 random variable here. So the random variable x denote number of queens drawn and random variable y denote number of kings drawn. Okay. So you have to find what is the probability that x equal to given y equal 1. Right. So what does it mean? That given you have drawn 1 king, what is the probability? Given you have already drawn 1 king, what is the probability of getting 2 queens overall, right? Okay, so first tell me, is this problem discussed in the activity session?
Yeah.
Yeah.
If it is discussed, I will not solve it. I will just explain what is there. Okay. So you have to find what is the probability that x equal to 2, comma, given y equal 1. So this basically means what is the probability that x equal to, comma, y equal 1 divided by probability y equal 1. All right. So if I'm saying x equal to y equal 1, what does it mean? You have out of this 4 card, you have drawn 2 queens and 1 king, right? What is this probability? So out of 4 card, what is the probability that you have drawn 2 queens and 1 king? So how many kings do you have? 4.
So
How
what
many?
we did is 4 choose 2 into 4 choose 1 into 44 choose 1 for the remaining cards, like picking up 1 card from the remaining cards in which kings and
Okay.
queens are
Okay.
not included.
Yeah. Okay.
So upon I did 4C2 into 4C1 into 44C1 upon 4C1. So I'm having doubt.
Why upon 4C1? You have total of 52 card, no?
Yeah.
So out of 52 card, you have to select 4. So basically in the denominator, you should have 52 choose 4. Out of 52, you want to choose 4. Now, not that you want to choose 1 out of 4, right? You want to choose 4 cards out of 52.
Okay, got it.
So I will not write it down because it has already been discussed in the last session. So
Yes, ma'am. No problem.
So I just, yeah. Okay. Yeah.
Excuse me, ma'am.
Yeah.
I have an issue in the same activity of question 2. Even I know it's discussed in activity session.
Okay.
But it's still I have a problem in this.
All right. So if x equal to t1,
Ma'am, please upload the notes for today's notes in the portal.
Today's notes on the portal.
The write-up you just
the write-up. Actually, it has been written down on the Microsoft account. Not sure if we can upload it. Okay, let me see if I can take a screenshot and make it on PDF. It's fine. All right. Okay. What is the first option? It says range of y given x equal t1 will always be same as range of y. Is it always true?
No.
No, right? Second one, again, not true. See this, I marked it by mistake just now. So what was second one?
Excuse me.
Range of x given y equal to 2, t2 will always be same as range of y. Is it true?
No, wrong. It's wrong.
Wrong, right? Because it is given at y equal t2, so it is not necessary that your range of x will always be same as range of y. Now, in the third one, range of y given x equal t1 can be different from range of y. So what about the third option?
Yes, it's
I don't
right.
think so.
It's right.
This is right.
Because
So,
can is mentioned, can.
yeah, can be different. It's possible that given x equal to t1, range of y is different. It's possible.
Remember, what is the difference between second option and fourth option? I mean, x, y is in different only.
Sorry, can you repeat again?
I mean, in the second option, x means of x, y is equal to 2 will always be same as means of y is incorrect. So, means of x.
Second option is what? Second option is given y equal t2. You know, you are saying that if y equal t2 is given, what is the range of x? So it can obviously will not be equal to range of y, right?
I understand second option, but why if second option is incorrect, so option number 4 is incorrect. Why?
Option number 4, range of, okay, given y equal t2, range of x will be same as range of x. It is also not always true.
But what is the difference in between these two? If one is incorrect, so second one. Third one.
Yeah, third option is correct, right here. See, I will give you one example. So are the examples discussed?
Ma'am, the same example in which there was 0 and 1.
Yeah, the same will work. The same example.
Actually, the 3 options except the third option means same thing. isn't it?
Sorry, repeat what you
all,
said.
all the three options except the third option means same thing. It
All
is
the option except the
Yeah,
third
yeah,
option.
means same thing because there is no surety.
There is no sure.
okay.
Yeah, it says will always be.
Will all say will be same, will always be same, will always
Yeah.
be same. That is not possible.
Okay, okay.
Yeah.
Yeah, thank you, ma'am.
Yeah.
And what is the difference between option 1 and 4? They look like same, na?
Option 1 and 4
That's
is
why
completely different.
that's why both of them are wrong, na?
No, that's not the reasoning to give. See, first says given x equal to t1, range of y, is it always going to be same as range of y?
No, it is not. Both our options are wrong, but they seem to be similarly worded.
Similarly worded, yeah.
Yes.
So whatever example we just gave, like if you put just one joint, probability to be 0, your range changes. So it is not always going to be same as range of y. It can differ. Okay. Let's
Can
go
you
back.
take an example of it?
Just here we had seen the example. Where is it? Yeah. So let's say this is very not clean.
Range can always differ, I guess.
Yeah, range can always differ. That's true. Okay, let's say this only. So what? Let's look at this.
And may be same at times.
Let's look at this. Given x1 equal to 2, range of x2 is going to be 1 here. Right? But it is range of x2 in general is 1, 2. But when x1 is given to be 2, range of x2 is coming out to be just 1. So it is not same, right? It is different. This 1, 2 is not equal to 1. Just think about it. Okay?
Can you please repeat that?
So, see, here given x1 equal to 2, the range of x2 is 1, right? But range of x2 in general is 1, 2, which is not same. So I cannot say that range of y given x is some t1. It is going to be same as range of y, right? It can differ.
Okay.
Here is what we have seen example. Yeah.
Yeah.
Okay. Let's move ahead.
Madam, if it would have been mentioned that the range would be subset of
Range will be subset of
the marginal one, then the joint PM, the joint distribution.
So you are saying the range, if it is mentioned that range of y given x equal t1 is in a subset of range of y.
Yes, ma'am.
Yeah, then that is true.
Then that will be true. Yes.
That will be true. Okay. Let's move ahead. Then, okay, you have an example here.
Marginalization is left.
Okay, marginalization is left. Let's do that first, and then if there is time, we'll do something.
Factoring of joint PMF is also left.
Yeah. All right. So these are the three topics that you saw: joint, you saw marginal, you saw conditional. So similarly, if you see all that for 2 random variable. Now, if you have more than 2 random variable, let's say I have n random variable. Okay. So let's say I have random variable x1, x2 up to xn, and they are jointly distributed. So fx1, fx2, fxn, again x1, x2 up to xn. Okay. So this is also going to be same as what is the probability that x1 is taking the value small x1, what is the probability that x2 is taking the value small x2, up to what is the probability that x3 is taking the value small x3. The same thing, we're just extending it to n random variable. Similarly, if you have to find the marginal, let's say we have n random variable and they are jointly distributed, then what is the marginal of x1? So this is again going to be, you sum the joint, okay? So you have the joint x1, x2 up to xn, okay? You sum the joint. So you will sum it over everything that is not there. Like if this is, let's say T1, T2, up to Tn, okay? So you have to find the marginal of x1. So you will fix your x1 and vary your x2, x3, x4 up to xn. All right. So you are saying you are fixing x1, you will vary your these two. So T2 belongs to Tx2, T3 belongs to or Tx3 up to Tn belongs to Txn. The same thing. So like when it was two random variable, what we were doing, if we have to find the marginal of x1, we were fixing our x1 and varying over x2. Now here in place of two random variable, we have n random variable, right? So if we have to find the marginal of x1, we will fix our x1 and we will vary our x2, x3 up to xn. We'll sum it over that. Okay. So similarly, let's say if I have to find fxn of Tn, then what it is going to be?
xn you have to keep fixed.
Xn, fix
vary
xn.
over all the
Fix
other.
xn and vary over
Vary up to n minus.
Yeah. So this was about when you have more than two random variable.
Conditional probability for random.
Conditional, yeah, we'll look at conditional probability also. Now we'll look at marginalization. So let's take the example for three random variable. So let's say I have x1, x2, x3, three random variable, and they are jointly distributed. So you have fx1, fx2, fx3. Okay. Now, if we have to find, if let's say from here we have to find fx1, fx1, x2. Okay. So we can write this as sum over fx1, x2, x3, and we will vary over t3. Yeah, we'll vary over x3, right? If we have to find x2, x3, right? And basically, what is x2, x3? This is this writing this, we mean probability x2 equal t2, comma x3 equal t3. This is what we mean. And we are saying this is same as sum over fx1, x2, x3, t1, t2, t3, and we are varying over x1. t1 belongs to tx1, right? So although like you had three random variable and you were given that these three random variables are jointly distributed. So if you have to find, let's say, the joint distribution of two random variable, we are treating it as the like we are finding it as the way we have found the marginal. Now we are saying this random variable x1 and x2 is like 1, and we are finding the marginal the way we used to do. So to find the marginal, we are just adding over T3. Then if we have to find the margin of like joint of x2, x3, we are treating it as a marginal and
adding over T1.
Over T1. This is what we call it as marginalization.
We have done it already, I guess, isn't it? In case of two random variables.
Yeah, we have done it already. Just a name we are assigning, we are giving it.
We call it marginalization. Okay.
Yeah. So basically, whenever you have to find the marginal of one random variable, you fix that random variable and sum it over other random variable. That's all you have to take care of. Now, if you have more than two random variable, how do you find the conditional probability? Let's say we have four random variable. So let's say we have x1, so we have x1, x2, x3, x4, and it is marginal, it is jointly distributed as x1, x2, x3, x4. Okay. Now let's find fx1 given x2 equal t2 of t1. So what is this? This is going to be fx1, fx2, t1, t2 divided by fx2, t2. Now, if you had to find fx1, x2 given x3 equal t3 of t3, right? So this you will write it as fx1, x2, x3 divided by fx3.
T3. Ma'am, here two values should be specified now because it's fx1, x2. It's
right,
x1, x2.
yeah,
So
that is right. This is t1, t2. Okay. So it's now once you know how to find for one random variable, you can two random variables, you can just extend it for n random variable, any number of random variables. So okay, now if you had to find fx1
Ma'am, a
given,
small question here.
Yeah.
And the second one, like f x1, x2 given x3 equal to t3, right?
Yeah.
It means, right, we have to find the probability of x1 being t1, x2 being t2, and x3 being t3, right, in the numerator?
Yes, yes.
Okay, thank you.
Okay. So, okay, if you have to find fx1 given x2 equal t2, x3 equal t3 of t1, what it will be?
x1, intersection of x1, x2, x3 divided by
fx1
x2 intersection x3. X2,
divided
x2,
by fx2, x3.
x2, x3, yes.
Yeah. So this is again fx1, x2,
x3 divided by
fx2,
x3.
right? This is how you will find. Okay, so what is conditioning and factors of joint PMF? It is okay. Let's take the example for four random variables. Yeah.
Ma'am, can you please scroll up for a second?
Yeah.
Sure.
And what we can say about its their range?
Sorry.
What we can say about their range?
About their range. Okay. Let's take one example.
Done, ma'am. You can scroll down.
Let's take one example. So let's write. You have x1, x2, x3, and you have fx1, x2, x3. Okay. Let's say x1 is taking the value 0, 1, 2, 1, 2, 3, 1, 0, 1, 2, 1, 2. Okay. Let's say these are the values that x1, x2, x3 takes. And let's say the probabilities are 1 by 4, 1 by 4, 1 by 4, 1 by 4. Let's say this is one joint distribution given to you. Now, let's say I'm asking you what is the range of given x3 equal 3, given x3 equal, sorry, wait. What is the range of given x2 equal 1, x3 equal 2? What is the range of x1? Can you tell me?
0 and 2.
0 and 2. Because you see here that x2 1 and x3 2, x2 1 and x3 2, you have two different values that x1 is taking, that is 0 and 2. So the range that x1 takes is 0, 2. Is it clear?
Yes, ma'am.
Okay. Now let's move to the conditioning and factors of joint PMF. Okay. So here what we are trying to do is, like, we are saying we can write any joint distribution in terms of conditional and marginal. So if I have, let's say, 4 random variable x1, x2, x3, x4 that are jointly distributed, so if x1, x2, x3, x4, and if I have to find fx1, x2, x3, x4 of t1, t2, t3, t4, we can write this as probability that x1 equal t1, comma, x2 equal t2, x3 equal t3, and x4 equal t4. Okay. Let's say I'm trying to split it here. Let's say I want this to be separate. So this can be written as if x1 given x2 equal t2, x3 equal t3, and x4 equal t4 of t1 times
Will you please
f,
repeat this line?
wait, times fx2 of t2, fx3 of t3, fx4 of t4.
Should fx2, fx3, fx4, t2, t.
Sorry.
Ma'am,
Can we write?
Ma'am, go ahead.
Wait.
Second term, I did not understand.
Okay, let's see. Can you write this as this into this?
Second term, I do not understand. It's a joint probability. X2, X3, and X4.
Marginal. That is marginal probability.
So this is joint conditional times marginal. Can we write it like this?
Yes.
Yes. Okay. So let's fix this. Now we'll proceed with the second term. So can we write the second term as f x2 given x3 equal t3, x4 equal t4 of x2 into f x3 x4? Can we write it?
Yes.
Second term as this?
Yes, ma'am.
Okay.
Ma'am, is it of T2 or X2?
T2, madam. T2.
Sorry, T2. Yeah.
T2. Yeah. Yes, ma'am.
Now,
And the above that one also you have written X4 kind of thing.
sorry.
In the above arrow mark, downside arrow mark, you have written X3, X4 kind. Yeah. So
X3 equal T3 and X4 equal T4. Okay.
above that one, I would just above.
Above this one?
Yes, ma'am.
I haven't written it completely. X3 equal T3, X4 equal T4. Okay, this is what it is written as. Now this can be written as this times this. Now we will fix this term, the first, and this one. Now we'll do this. So this can be written as f x3 given x4
x4
equal t4
of
of
T3.
t3 into fx4 of t4. So what you have seen here is, like, if there were 4 random variable and they were jointly distributed, you can always write those, you can always write a joint distribution in the
Form of conditional one.
marginal, yeah, in the form of conditional. So this is called like conditioning and factors of joint PMF. You had the joint PMF given and you are writing it in different factors and you are writing it in conditional form. So this is where this week 1 ends.
Hello, ma'am.
Ma'am, we are left with examples, word problem examples. You said we will be discussing it later on.
Oh,
So, ma'am,
okay.
Practical applications type.
Okay, practical applications type. Wait.
All the 5 things, ma'am, that we will discuss the practical application of all the.
All the 5 things.
Yes. Why only one example, maybe, ma'am?
All the 5 things. It's already 8 o'clock. So we have time.
We can do it next week. Just note it down.
Okay, fine. So yeah.
I have a doubt, ma'am. Tutorial. Week 1 tutorial. Question number 16. I didn't understand the Poisson distributions. So how to calculate this?
Wait, let me go back there.
For the Poisson distribution, I think you should have go with the live session that are being attached in your set.
I already saw, but
it is tutorial 1. It is tutorial 1.
Yes.
Which question?
Question number 16. I think 60 to 19.
Okay.
60 to 19.
Yeah, okay. Okay, so this is one problem where you're going to see the conditional, marginal, and everything. So what does this question says? It says number of emails received by a person in a 1 hour interval, okay, is Poisson random variable with the parameter 15. Okay. So let's say you have different time intervals, 1 hour interval to 1 hour interval, and you will observe how many emails are you going to receive in each of the in each hour interval. Okay, and we are saying that models a Poisson distribution that is given by random variable n and parameter 15. Now assume that the probability of an email being spam, so you are receiving emails, so either the email can be spam or it can be like fine, non-spam, you can say. So any email you receive, the probability that it is going to be spam is 0.2. And what we have said is X denote the number of spam emails received in an hour. Okay, in an hour, how many spam emails do you receive? Okay, so question number 16 says, if 12 emails are received in a 1 hour interval, find the range of X. So what is going to be the range of X? If you have okay, if in 1 hour interval if you have received 12 emails, how many emails can be spam? Let's say
Ma'am, it is given spam emails is X.
Spam email is X, it is fine. So if you are receiving 12, let's say if you are receiving 12 emails, how many emails can be spam?
Anything between 0 to 12.
Maximum 12.
0 to 12. Either
0 to 12.
none of the emails are spam, or one is spam, or all are spam. Sorry, what happened?
Ma'am, it has nothing to do with 0.2 that is given, right?
Yeah, it has nothing to do with 0.1 that is 0.2 that is given. So from here you can see the correct option is B.
Ma'am, reason please, ma'am, please.
See, let's say you have received 12 emails, or let's say you have some 12 items, okay? You have some 12 items.
Yes,
and
ma'am.
I'm asking you, check how many are defective. So like how many of them can be defective. So it is possible, there's a possibility that either one item is defective or two is defective or none is defective or maximum 12 is defective.
All are
So
defective.
similarly, if you have if you have received 12 emails, okay, if you have received 12 emails, then out of those 12 emails, how many can be spam? You have to find the range of x. So x is nothing but
1 to
number
12.
of spam
0
emails.
to 12. 0 to 12. Yes,
X,
ma'am.
x is number of spam email received in an hour. So
That's
that is
in.
why range is 0 to 12.
Okay, ma'am. Yes, ma'am.
Hello, ma'am.
Yeah.
Ma'am, in tutorial 2, I have a question, doubt in question number 1.
Okay.
Week 1 tutorial 2.
Ma'am, it is not completed.
Oh, you wanted to complete that?
Yes, I didn't understand Poisson distribution. That's why.
Okay. All right. Now you have to find f and x. So basically, what is n? N is Poisson.
And yes, 15.
Okay. So all of you were asking about where are the applications. So here you will see the application here. See, you know that n x given n going to model binomial distribution here. X given n is binomial.
Because 2 events are there, na?
Yeah, like
parameters are there.
We have to
given
choose
n.
the number of spam from 12 mails.
Yeah, like basically in 1 hour interval you are receiving n number of mails. So out of n emails, how many are spam? So basically it models a binomial distribution.
Yes, ma'am.
To solve this problem, go back to lecture 1.4. So there is one example you will get, that is Poisson number of point tosses. Please go and check that example once.
Okay, I already saw but didn't understand.
The solution,
So I need to
did you check the solution? Did you check the solution?
No, I saw already content. So I am professor.
Week 1 tutorial 1, did you check the solution?
No.
No? Okay. If you are not able to understand this, please watch lecture 1.4 and watch that example. From there you will understand why is it binomial.
Excuse me.
Okay, ma'am.
Yeah.
Yeah,
Thanks,
if you can add on, I think in that lecture itself, sir has given the formula for Poisson and binomial together.
Yes.
If you can just substitute the values from this, I think you'll be able to get it.
Yeah, but just substituting the value without understanding is...
No, after watching the lecture, I'm telling you.
After watching the lecture, once you understand, you just substitute and we can get. Yeah, that is fine.
I'm from tutorial 2, question number 1.
Tutorial 2, question number 1. Yeah.
Yes, ma'am. Actually, ma'am, I tried to solve this question, and from the given information, I'm not able to get on the condition which is given in 1 by n into n minus 1.
Okay, so according to you, what should be the answer?
Ma'am, actually, I got the answer 1, but I'm not able to come to make the situations for 2 by n minus 1.
Okay.
Maybe just need to some startup or a brief.
Do you have a table in the solution? Is the table made in the solution?
Actually, ma'am, there is a table available in the solution.
Table is there.
But it already shows the condition directly 2 by n minus 1.
Okay, why is it 2 by n minus 1? See.
Yes.
You have n tickets. Okay.
Yes.
And tickets are numbered from 1 to n. Now you are drawing 2 tickets without replacement. So you without replacement, you are taking 1 ticket, you're not putting it back, and you are drawing another ticket. So what is the probability of So if you want to find the joint distribution of xy, so fxy means what? Probability that x equal x, y equal y.
If there is a replacement, then the probability for both the tickets will be 1 by n and 1 by n.
Yeah, that is fine. So see, it is basically 1 by n. Probability of taking one ticket, like x equal, let's say x, that is 1 by n. Probability y equal y is again 1 by n minus 1 is fine. But it is possible that the first ticket that you observe is not x, it is y. So you can, instead of like getting xy, you can also have yx.
Ma'am, actually I confused because just like we have a number of tickets 1, 2, 3, 4, 5 up to n. So just like we choose the first ticket 6, just we choose that 6 number ticket, then we have then we don't have the options to choose a ticket less than 6.
We don't have the option to choose the ticket less than 6.
Actually, as per the condition, y random variable will be the number greater than x.
Yeah, y is greater than x.
So if we choose some number, then the option that we are left for choosing the y will be the n minus x.
N minus x. Okay, this is, okay, let's say in place of this n tickets, I'll give you, let's take it the simple example. Let's take 3 tickets. Okay. What I'm saying is, let's say this is your on, and in this one you have 3 tickets. Let's say ticket 1, ticket 2, and ticket 3. And now you are drawing 2 tickets from here.
Okay.
This is without replacement. Okay. So you can have the first ticket to be T1, second to be T2.
Yes.
First can be T1, second can be T3. Right?
No, ma'am, T3 cannot be possible because we have to choose the second ticket which is greater than first ticket.
No, it's not.
It is not said in the question. Is it said?
Yes, ma'am.
I don't.
It's not like x is chosen in the first toss and y is chosen in the second toss.
It is not. It is not. It is just one example that is given there. That is why we have multiplied it by 2. So, like if you're taking just 2 tickets, okay, so you can have T1, T2, you can have T1, T3, you can have T2, T1, you can have T2, T3, you can have again T3, T1, and you can have T3, T2. And
so second ticket can be less than first ticket.
No, forget about less than, greater than. Okay. Forget about it. So I'm saying the 2 tickets I have gotten is T1 and T2. These are the 2 tickets that I got. Okay. So what is the probability of getting that? So you have 2 cases, right?
Yep. Okay.
So from here you have 1 by 3.
Okay, got it.
You got it?
Got it. Yes.
That is why I'm multiplying it.
Ma'am, one question is also then assignment, ma'am. Question number 4. Practice assignment, question number 4.
Practice assignment, question number 48. Practice solution has not been uploaded.
No, ma'am, it is not uploaded yet.
Okay. Yeah, tell me.
Actually, ma'am, here x is uniformly distributed above 1 to 6, and y be the number of times 2 occurs in number of throws of a fair die.
X throws of a fair die.
Yes, ma'am.
So, see, we are saying x is uniform in 1 to 6. So, probability of each of it is 1 by 6. Now, how you are defining y to be? Y is number of times 2 occurs in x throws of a fair die. Let's say now x is taking 1 to 6 value. So if x equal 1, okay, so given x equal 1,
y will be 0 and 1.
number of times
Number of time 2 will be occurs. So a 2 will be occur will be 0 time or a 1 time.
so, yeah, so X throws means you are throwing your die once. If you are saying X, okay, forget, you don't even have X equal 1 here. You in the option you have 2, 4, 6 and 5. Okay, this is all you have. So
Last option though I know it is 0. It cannot be possible when we got the X5 and we got the 6.
Yeah, it means you are throwing
it is 0.
You are throwing the die 5 times and 2 is
And
against 6,
getting the 2 6 times. Yes.
It is already even okay. Now you have to look at option 1, 2, 3.
Yes.
So option 1 is like you have thrown the die twice. What is the probability? What is the probability that 2 occurs?
2 times.
Yeah. So you see, y, okay, you see that y given x, it models the binomial distribution.
Yes.
Is it? So y, you can directly say that y given x is binomial x comma 1 by 6.
1 by 6.
Yeah. So from there, can you find the first, second, and third option?
Actually, I got the answer wrongly because as per the answer provided, option 1 is incorrect. But my answer coming to 1 by 6. And as per my
I do not even
calculation,
understand what is the experiment over here. How many times are we throwing the die? First we do the experiment and from that we calculate the value of random variables. No, here random variable is like the experiment is variable. How many times we are doing? I've seen that kind of distribution only in geometric distribution. We have seen like we are keep throwing, but in all other we haven't seen this kind of distribution. We experiment. How many times experiment is happening is itself variable. We have seen that only in geometric distribution.
Sorry,
What is the experiment?
What you're saying?
Saying what is the experiment here? The
Experiment
number of
is,
times we are throwing the die is itself variable, right?
Yeah, you are saying that x is given to you, okay, and let y be the number of times 2 occurs in x throws of a pair die. Basically, x throws means what? 1 throw, 2 throw, 3 throw, means number of whatever x you observe, you are throwing the die x that many times. So if let's say x is 1, so I'm saying you are throwing the die once, and how many times 2 occurs in that? So that is 0. If I'm saying x equal to 2, so how many times 2 occurs in that? So basically, y given x models the binomial distribution.
So x is separately given to us. It's not associated with the die.
Yeah, it's not associated with the die.
So we are taking random variables from different things and then working with.
Practice solutions are available, is it?
Yes, ma'am.
Okay. So what is given is x is uniform in 1, 2, 3, 4, 5, 6. The first, and it is that y given x equal k is going to be binomial distribution with n to be k, and this is 1 by 6, right? So if you have to find y equal to given x equal to 2, this probability. So this is going to be just 2 choose 2, p to the power 2 and q to the power n minus 2. So what is this? This is 1 by 36, right? It is not 1 by 6.
Yes, ma'am. Yes, ma'am. Got
Yeah.
it. Mm-hmm.
Yeah, if the
Got
solutions
the
are
answer.
available, like, please check there.
Okay. Thank you, ma'am.
Yeah. Thank you. All right. So let's close the session for today
Just,
now.
hello, madam. This is, I
Yeah.
wanted one clarification regarding graded assignment question number 1.
Okay.
Just clarification, not the solution, just a clarification.
Okay. What is the doubt in there?
In that they are saying that 3 coins are tossed.
Yeah.
And then they are talking about first toss, second toss, and third toss. Does that mean that all the 3 coins are tossed 3 times, or the first toss means the toss of the first coin, second toss means the toss of the second coin, and the third toss means the toss of the third coin? So in that I was not understanding the question. That's why
I think in this question, all the 3 coins are tossed at the same time, and then the conditions
So
that come
are there 3 coins tossed together 3 times, or the first coin is tossed in the first toss, the second coin is tossed in the second toss, and the third coin is tossed in the third toss?
No, all the 3 coins are tossed at the same time, but only one.
But they are talking about first
not
toss,
3.
second toss, and third toss. They're talking about first toss, second toss.
Just like there were 3 coins and we tossed and a 3% and 3% tossed all the 3 coins at once, and then the conditions X and Y and Z all are
So
found.
I was not understanding the question. That's why I brought it up.
Yeah, it's the same thing what you just explained.
So is it that all the 3 coins are tossed 3 times, or
No,
is
it is
that
all the 3 coins tossed only once at the same
Like
time.
you say, you have tossed 3 coins, you get.
So first toss means the toss of the first coin? We're talking about first toss. What does first toss mean? First toss means. Can you open the question, ma'am?
Oh yeah, just give me a minute.
Or it may be just like if you have a 3 coins and tossed at once and second and third.
So we are talking about toss 2 and toss 3. Does that mean toss 2 means toss of the second
Graded
coin?
assignment. So you are going to have one solve with a session. Let's discuss the graded assignment there.
Okay, but I just wanted to get the clarification
It
regarding
just when you are tossing 3 coins, whatever outcomes you get, basically.
So we are talking about first toss here. That's why I talked.
Your first toss, let's say on the first toss, you got the first head. So second toss.
So first toss means toss of the first coin, or all the 3 coins are tossed 3 times. First toss means toss of all the 3 coins together, or first toss means the toss of the first coin. That is not clear. That's why I asked.
Okay, let's take it as toss of the first coin. First toss means toss of the first coin.
Toss of the first coin. Okay.
Yeah.
Okay.
Yeah, let's close the session for today now. We'll have more sessions
Ma'am,
the next week.
Actually,
yeah.
Hello.
Yeah.
Actually, I already go through all the videos, and already when I try to solve all the question, it will go all through well. But even then, after solving all those questions and getting the answer correct, I am not able to get confident on the questions. So what can I do? I will do or more practicing, or there is something else can I do?
Do practice, do problems, solve more problems.
Okay. Maybe those questions try to solve again and again, and maybe solving the new problems. It will be helping out.
Try to solve new problems.
Actually, in activity and practice, no, the solutions are given. So it is easy. So we get confidence from that. In graded, the solution is not given. So sometimes we are confused. What could be the solution in that? In activity and practice, solutions are already given. So if we get the answer wrong, we can somehow work towards the right solution. But in graded, we are not confident because we don't know the exact solution of the graded assignment. So we are not confident about, even after solving all the practice and activity questions, it is very difficult to be confident about the graded assignment.
Yeah, practice some more problems. Some reference book has been given to you. Try to pick the problem and just try to do it on your own. Like even the practice and the activity, whatever you tried, right? Like don't always go and look at the solution or the answer and then solve.
Yes, yes.
That way,
First we solve it, and
yeah,
then when we click on the submit button, we
yeah,
get that so many answers are right and so many answers are wrong. So when we get that this answer is wrong, we try to find why we went wrong, and we somehow get the right solution for that answer if we work towards it.
yeah.
But in case of graded assignment, we don't have the solution. So it is very difficult to be confident about the answer about the
It
graded.
will come with practice. It will come with practice.
Yes, yes. And sometimes even in statistics 1, it was sometimes it was a question of interpretation. The interpretation, what we interpreted was wrong. So that's why our answer got wrong. When in statistics 2, I faced that problem. That sometimes my interpretation of the problem was wrong. Because of that, I got the answer wrong. So that also is a factor in.
I have a. Can we just take 5 minutes on one doubt?
Okay, what doubt do you have?
That screw was a problem.
Sorry?
That screw problem we discussed at starting.
Okay, the same problem.
Yeah, actually, so first we should discuss choosing R objects from n identical objects.
Okay.
And I say there is only one way to do that. It's not NCR. There is only one way to choose R objects from n identical objects.
No, you have.
I'm just putting a reference. I've gone through some books also, but I'm putting a reference of a website. Okay, so just pasting the link in the chat box.
Okay, Smile, can you put this link on discourse?
I will put check. Link of the website in.
Yeah,
I've gone through some books also. It's
okay,
very.
okay, it's fine. You just put it on discourse. I will check what is there and what they say, and I will reply you there. Okay. Just you are on discourse.
Yeah, I am.
Yeah. So just go back and put your question there, and just tag me so that I can see. Okay. All right. So. All right. So that's it for today's session. We'll meet again next week. Yeah?
Okay. Thank you, ma'am.
Practice the problems.
Thank you.
Thank you. Thank you all.
Yeah. Thank you.